How do I build it together? How do I lead you in order to choose the right solution for our needs? And it really depends on the case. When you're doing a big migration, then it has a lot of complexity and a lot of people involved. You cannot be the one that knows it all. And you shouldn't. You should trust your fellow and your colleagues and your team members. So you need to be focused about the entire pipeline, by time chain, but you need to be able to trust the team around you as well. Hopefully it answered your question.
All right.
I think we have time for one more.
One more. We have for one more. One last question. If there is any desire.
Yeah.
Oh, there it is. Please stand up. Ready? Yeah.
Great catch.
So you have the...
Celebrating win, come on.
Yeah. Thank you for the support. So you have your architecture and client.
I'm sorry, I don't hear you.
You have the architecture and the client comes at the day, the last day of the delivery of your architecture and changes the requirements.
Sorry, I will come to you because I can't hear it. And I'll repeat the question.
It will have a feedback if I...
So if I can repeat the question for you.
Oh, okay.
Yeah. So
I'm
a
sorry,
client comes at the last day of delivering the architecture and changes the requirements.
Yes.
Okay. Life, basically.
Yeah, actually.
So I will give you an example.
Yes,
that
that's
was
the question.
my bad. And one day before delivery, discovering I missed something critical, security breach. I'm talking about a huge one. And we are a few hours before going live. The campaign already was set. Everything is scheduled. What do? So yeah, we realigned. We understand what our options, and we went live with a small MVP that was secured, that didn't include all the features that I wanted, that were ready, but the service was live and the system was reliable and safe. So that's one example. Another example is that another service, we talked about the challenges the same day before actually deploying, and I'm talking about an example before we had CI/CD. So deployment was a long process. And we need to do the deployment. Customers are already waiting for the features. And suddenly, the product team said, hey, I forgot to tell you something. Are you sure it will answer that and that need? Like, no, we talked about it. You remember? We talked about it 2 days ago, last week. I have it in my notes. No, it's very critical. And then you have a decision. Are you going live or not? And in that case, we decided to go live and fix the damage later. It was a very painful holiday, I have to say. While I was on vacation in Mexico, I had to write the code to fix it. But life, basically. And like everything that we do, we iterate, we rearrange, we set priorities, we think about, again, what's the need. And I have one tip to be proactive in that regard. Ask questions if it wasn't clear. Because in a lot of time, and I can give you also a lot of example for that, a lot of time, by asking the right question, by challenging the people, oh, why do you need that? What's the customer use case? What's the feature will do? What's the reasoning behind it? You actually solve it beforehand. You actually understand the priorities better, and you also let other people know the priorities better. So you build a trust, you build a partnership, you're working better together because you're communicating better.
Thank you.
Thanks.
Okay, a big round of applause for Eilert. See you in 11 minutes for the next talk.
Not, could it be better? Or
We are starting in 7 minutes, just to let you know. We're starting in 5 minutes. This is track 1. But 3 more minutes. We're starting in 3 minutes, so please take your seats. We're starting in 3 minutes. Two more minutes. I'll take the time. All right. Please take your seats. This is track number 1. Track number 2 is up the lounge to the left. And I want to remind all of you that we have a quiet room in case you need some quiet time or to get some job done. The access to the quiet room is through the overflow, which is to the right, 3.1, just so you know. All right. Our next speaker is Martine Chou. He's a software architect at SBTech with a lot of experience in the industry. He's going to talk about Solid Principles Part 1 of 5, S, the most misunderstood principles. So, big round of applause for Martine.
Boom. Okay. Hey guys. So as you already know, I'm Martin. Let's at least mention the industry. I'm coming from the sports betting industry. This is where I have a lot of experience. And this is where solid principles are very useful, probably in other places as well. I want to tell you that I'm starting with a lot of handicap. I forgot my glasses this morning, so I cannot read the notes. So I'll be kind of free rolling it. We'll see where it goes. I want to start with the usual questions around the room. So I want to know what kind of people I have at least around here. You know, how many of you are software developers in general? Okay, most of you. This is very nice because I've spoken to places where there are no developers. How many of you are doing only back-end development? Okay, how many of you are doing front-end development? So okay, there are a lot of developers that did not raise their hands. So please shout out, what are you doing? Okay, so Facebook waste of time type of development. Okay, do we have any marketing people, any business people in the room? No? Good. Now we can talk business. All right, so I'm going to be talking about the solid principles, but I'm going to focus on only one of them, and there is a reason for that. But before that, I'm going to talk a bit about what is a principle, and I'm going to talk then about what are the solid principles, what is responsibility. Then we're going to do a deep dive into the single responsibility principle, and then we're going to do a quick summary and go to drink some coffee. Okay, so principle. What is principle? This, as you may notice, is copied from Google. Very nice source of slides for me. So this is universal truth, right? Fundamental truth. And this is very, very hard word. Like, you cannot just use principle on general. It's either a principle or it's not a principle. So what are the solid principles? There are 5. Guess what? We have 5 letters. So 5 principles. So there is the single responsibility principle on which we are going to do a deep dive today. There's the open-closed principle, which states that a component or a module should be open to extension and closed for modification. Then there is the risk of substitution, which basically is subscribe to a contract. That's it. You need to be able to substitute a type with a subtype. Then there is interface segregation, which means basically it's better for you to have many small interfaces, very specific client interfaces, than to have one general purpose interface. And then there is the dependency inversion principle. Dependency inversion principle means that you should be dependent on abstraction, not on concrete implementation. So, solid principles are coming from the guy. Okay, it's your left, from the guy on the left. He's called Robert Martin, and he kind of invented them in the early 90s, and he put them aside as the first 5 principles of good software design. Then this guy, Michael Feathers, Michael Feathers found that their names could be rearranged into this abbreviation, SOLID, which makes them a lot more memorable for people. What else can we say about the solid principles? Well, solid principles are names for concepts. What this means is that they give us the ability to express ideas and solutions to specific problems. They are heuristic in nature. So this means that they're not like word by word the same principles as the word principle implies. What is a heuristic? So let's say living a healthy lifestyle would make you less prone to disease. That's a universal truth, right? But it's not always correct. So the solid principles are this kind of principles. They are common sense, although it looks like it's not very common if we have to talk about it. And they are discipline. They make the developer sit, think, and reconsider if what I'm doing is right. Should I do it this way? Why am I doing it that way? When we're saying what the solid principles are, we should be saying what they're not as well. They're not rules. They're not laws. They're not perfect. Solid principles are observed in the wild to lead to success. They're making better software applications, more scalable. It's easier to develop applications which are following those principles. But there are a lot of successful applications which are not following those principles, which means that success is not pure function of the solid principles. Okay? You need to have critical thinking applied. You need to think, decide. In this case, we are going to follow this principle. In this case, we are not going to follow this principle. So why am I focusing on one and on the first one? Actually, this picture, it looks to me that it's impossible to do solid talk without it. So this is why I'm showing it. It looks like it's a, let's say, a principle to show this picture. So this principle, in my opinion, is the most misunderstood of them all. And the reason for this is that people don't spend time on learning the single responsibility principle. This is a very, very interesting principle. Usually what happens is that when we teach developers to do software, we teach them to do something simple. We teach them to do a method or a function. And what we say is that a function should do one thing. And then we say that a function should have single purpose, ergo, single responsibility, kind of flies in that direction, which is wrong. But why? First, we need to understand what is responsibility. And when we're saying this, we're not talking about the responsibility of the dictionary sense. So this is not the dictionary definition of responsibility. When we're talking about responsibility, the guy who created the solid principles is saying the following. A class should have only one reason to change, which changes things dramatically, right? So it's a poor choice of name. It's a poor choice of name for a principle. So let's try to do like example, okay? Like real world example with a shopping cart. Okay, not that kind of shopping cart, this kind of shopping cart. So this shopping cart was copied from the internet. I did not think of this one, but this one is representative for most of the shopping carts that you can see. And this shopping cart shows a couple of things. So we have some items that we're buying, obviously. They have some prices and some discounts. We have a total price and some tax applied, some other items that I don't see without my glasses. And we have the checkout button. Now, obviously, in a 30-minute talk, I will not be showing you source code, but let's think about this picture in this way. So we have a shopping cart class. Plus means this is a public field, minus means it's a private field. And let's do a show of hands here. Can you agree that this is the same shopping cart as in the previous slide? Yes or no? There are a couple of methods missing here and there because I want to simplify it, or I don't want to show every possible field. But more or less, this is a cohesive looking shopping cart. Single responsibility principle is about cohesion. So we can all agree this is a shopping cart only by reading the methods. We see that it's a shopping cart. We understand it by the signature of the class. So that's the single responsibility principle. See you later. Oh, I'm joking, of course. There is a higher meaning to the single responsibility principle. I don't know if you know Melvin Conway. There is something that's known as the Conway's law, which is actually not a law, but people are referring to it like this. I'm going to read it out loud, but it's going to be hard for me. Organizations which design systems are constrained to produce designs which are copies of the communication structure of these organizations. So what can we assume about the communication structure of this organization? Everything is in the same class. It's a cohesive structure, we understand. Everything belongs there. This is what is a shopping cart. It looks like that we basically have two developers from this class. This is how I see it. And they are never working on the same item at the same time, which is amazing. I don't know how they achieve that. But let's say the organization grows. And now we have a team which is dealing with accounting stuff. This can be the chief financial officer team. They care about different taxes in different regions. They care about different specific things that are related to how money and stock is reorganized inside the company. So they care about some of those items. And by they care about some of those items, it means that if we suddenly have to change the way we do taxation, they need to check out the code and implement the difference. Okay? So they are a stakeholder. When we are talking about design principles, usually we have a lot of stakeholders. This is why we are calling the groups of stakeholders which care about the same component an actor. So this accounting guy, stick figure, this is one actor. So let's move. What other actors do we have? So we have the presentation actor. Presentation actor are going to be all those stakeholders and people which are dealing with the front end, let's say. This is the client application. This is the front end developer. This is the, I don't know, the guy who implements the JavaScript for validation, and so on and so on. They obviously care for those fields as well. And the problem is that they care about the same fields. So imagine the situation where the two actors, developers from the two actors are actually checking out the same code. One needs to implement new taxation policy for, I don't know, Romania. And the other guy needs to change the format of the number to 1/000.00 currency. They're checking out the same code. This is a merge. One very good way to know that we have a problem with responsibility in the system is that we merge code from different teams or different developers. Let's put somebody else in the picture. Marketing actor. So what would a marketing actor care in this situation? Well, they will most probably care about the way discounting works. So they can do campaigns in different systems and so on. They will be able to offer bonus codes with flat rates or with fixed prices and so on and so on and so on. So now we have this web of responsibility around. Now I want to ask you something. Let's say this method, which method? This method breaks. Who broke it? Accounting or marketing? Well, obviously, who asked for the pull request second, right? The first guy merge goes automatically, and then the second guy has an older version of the code, so there is a merge conflict. Now, if they are a responsible developer, they will probably handle the situation in a good way, or they will say, resolve using mine. And then suddenly, we have some friction between the teams. So let's remove the lines and look at this picture in a bit different way. All the red lines, right? Those are different responsibilities. Let's refactor this from the point of view of accounting actor. Accounting cares about how you do price calculation. So we should make a price calculator. Now, at that point, the shopping cart is no longer a single entity. This entity is actually aggregating other entities. So we're going to call it shopping cart facade, okay? What facade pattern gives us generally is simplifying multiple ugly APIs into one simple API. And since this is being used on the client, this should be a facade. Then we need to care about placing the order, and we should take out placing order. I want you to notice that one of the methods left there, right? We still have place order method. Well, obviously the public API should be able to call place order, so we need to still have this method. But this is not the same method. right? This method depends on some kind of DI mechanism that is going to inject the cashier and so on and so on. Let's take care of our friends from marketing. We love those guys. So marketing people care about discounting policies and so on. Let's create a promotion class specifically for them. And they can do whatever they like inside as long as it works, as long as it has interoperability with our main class. So how does this picture help us? Now instead of one class, we have 4 classes or 4 components. But we have 3 distinct domains. And we have only associative links between those classes. It means that the shopping cart facade does not understand what is a cashier. The cashier is injected. Okay? This is a very important distinction. This arrow does not mean dependency. This is association. How do we manage this? By having simple interfaces, client-based interfaces. So let's say we are going to have a cashier, a price calculator, and a promotions interface. Let's move this a bit and put the interfaces here. The 3 interfaces obviously connect the different pieces together. And if you're already fed up with the arrows, let me show you a clearer picture without them. So we have 3 domains. We have the presentation domain, we have the accounting domain, and we have the marketing domain, and we have the interfaces in between them. So what do we see here? We see that we can do, as long as we don't change the interfaces, we can do development separately. So we can have new versions of the cashier, new versions of the price calculator, new versions of the promotions without ever touching the shopping cart facade, as long as the interfaces are intact. And by chance, we also find another principle here. Can somebody guess the other principle that I'm talking about? It's not part of the solid. Come on, shout out something. Let's make it fun. Separation of concerns, somebody said. I'm talking about the opposite principle of separation of concerns. Think about it. Come on. What is the opposite of separation? It's coupling. So here we can think about those 2 classes as the same package. This might not be the case, but this is a very interesting principle. It's the common closure principle. What this means is that classes that are changing together and that we are releasing together should be packed together. Why should I have 2 separate release processes? If I need to release cashier, I need to first release price calculator. So I'm keeping them together. Now, this is not always mandatory. Obviously, if the cashier class is changing very often and the price calculator not, it doesn't make sense to group them together. But this is a very interesting side effect of splitting our classes in this way. It gives us the ability to actually combine them into packages. This doesn't mean that we are developing them together. This means that we are releasing them together. Now, for the more observant of you, this picture actually asks, what about dry? Because I'm not crossing the boundaries. I'm not crossing the domain boundaries in this picture. There are only the interfaces. So how do I do code reuse? Well, I copy-paste it. I know it sounds counterintuitive, but we always prefer duplication of the code, but not coupling between the components. What's more dangerous to have? If I change one component, I need to rebuild and re-release 150 components, or it's safer to have one code repeated 2, 3, 5 times, but inside of the same domain. So let's move back to this picture. The more observant of you probably noticed that I did not talk about the data here. When I was splitting the responsibilities, I didn't talk about the items. What is an item? What is a product? And when I'm saying that we should have repetition, I'm talking in a sense that we should have a domain-specific language saying that we have presentation item, we have asset, and we have promotional item, or whatever. And the point is that you have the ability to correlate those items. This is what's important for you. you have the ability to correlate them. It doesn't matter if it's an ID, if it's a separate service that is doing that for you, but you have some way of saying that this item is that asset, which is this promotional item. What is this way? How do we do that? I don't hear anything, so please shout out. Again? Reference? Nah. You see those red boxes? This interface, the place order interface, this interface specifies that you need to do some kind of contract. So you need to give me item ID or asset reference ID code or whatever. It's not by, maybe I did not understand what the guy said about reference, but it's not like reference in memory. It's some kind of reference property, I guess. So we have the ability to correlate those items, which means that even if I have the same model, eventually those models are going to depart. And I should not be in a situation where accounting needs to add items to the model, and I need to rebuild my code just to make it work with the new model. We should not be doing that. Let's go back to the nice picture. So what other changes can we have here? Now, this is a trick question because those are changes that are not going to come from us. So what I'm going to talk about right now is external factors. So our code is pretty well split for this simple example. So if we want to go to a new market, which needs different taxes, we are going to implement a new price calculator. And eventually, if the price calculation is the same, but only the percentages differ, maybe we can make the tax calculation configurable, or maybe we can make it as a separate class altogether. But again, it depends on the frequency of change. So again, single responsibility talks about responsibility to change. How many things can influence me to force me to rebuild and re-release? So taxation, as I said, maybe there is a new way to calculate VAT in the country. Maybe we want to start selling items which have different taxation method in the same country. Maybe we need to go to a new market, or we want to go to a new market. And in that situation, we need to implement a new way of taxation. What about promotions? So let's say up to this point, we were offering percentage promotions. And suddenly, our marketing decides, okay, now we want to give flat rate. We want to suddenly be able to give you 15 euro off, not 15%. External factors, governments may change. So if you're dealing with a regulated kind of goods, you obviously need to change the way you do it. Let's say you have this situation. Recently we had actually in Bulgaria, NAP, kind of the Bulgarian IRS. They want to have a record of every online transaction that ever happened in an online shop. Obviously, all the online shops that have been developed in the past 15 years don't have that. Guess how many of them are PHP and they will never be able to do that. That's a joke not about the quality of the language, but imagine a project from 15 years ago on PHP 4.5 or something. This is the extent to which developers will need to cope with this, or businesses will need to cope with this. Other things that may change. External APIs that we are using. Let's say the API that marketing guys are using in order to track purchases changes. They want to migrate to a new version. Or the old one gets completely deprecated and let's say Google stops supporting it. It's not that this happened before. All right. I think that's about all that I wanted to tell about the single responsibility principle. I'm going to do a short summary, then we can do some Q&A. So the single responsibility principle is probably the most hard to follow. It's hard to follow because it requires us to think. We as people, we are hardwired to put things in groups. And when I see a shopping cart, I'm talking about online shopping cart, obviously. When I see an online shopping cart, it makes sense to me to have all those different methods, and it's intuitive to put them there in the beginning. And it's very hard for us to break off and start understanding, okay, this is not okay. Maybe we shouldn't have done it this way. There is responsibility. As we said, responsibility is reasons to change in the context of the single responsibility principle, obviously. So reasons to change are reasons to change from, they're coming from people, okay? They're not coming from software. They're coming from different agendas of different people, of different units inside of your company. So the accounting actor, as we defined it, they have one way of interacting with the world. The presentation has another. The marketing has a completely different one as well. So those are different reasons for your code to change, different agendas. You need to think about this. And one of the ways to think about this is to sit and discuss it with your colleagues. Those principles evolve over time. Code evolves over time. Maybe in 20 years when we have different languages and different ways of developing software, they will also change. So we need to constantly update and refresh our minds. We should not be doing software the way we've been doing it last year. We should always make it better. So tomorrow when you do new development, do it a bit better. Always fix something. Next time you do a commit, if you see something bad, don't fix the whole project. Fix 10 lines, fix 5 lines, improve it. Always leave the code a little better than it was when you found it. So reasons to change, as I said, are not always under our control. However, what is under our control is the way we design the system. And we can design a system that can be flexible to change, that will be easy to change. Let's say in the shopping cart example, let's say if the add item method is changing constantly, and if we need to recompile and re-release the entire application, do regression tests on the entire application, this is a rigidity. Our system is rigid. This is a problem. This is a design smell, if you will. But if this method is never changing, or it hasn't been changing in the past 10 years, and we split it in a way that we can handle this needless complexity. So when I said that those are heuristics, we need to always apply critical thinking. We cannot be in a situation that we're following them by law. You are the lone developer, you do it one way. Now you have 2 developers, they communicate, it's fine. Then the company grows, those 2 developers become team leads, but now 2 team leads interact, and let's say 5, 10 developers don't. They don't even know each other. The company grows more, now you have tens of teams. Now delivery managers interact. Not developers, not even team leads. Probably even not the architects. If you have a company of 10,000 people, how many of the architects inside the system are going to know each other? Probably those who share domain boundaries, but not all of them. So single responsibility principle is a principle about people needs, about stakeholders. It helps us define a system in the way that we'll be able to change it without affecting other people, other people's code, other people's modules. I mentioned some symptoms. The biggest symptom to look about is code merges. If you have to merge code from different developers on the same component, you have a problem. Split it. That's it. So simple. Okay. I want to finish with a quote from Phil Hack. He was kind of a program manager at Microsoft, then he was doing something at GitHub, director of engineering or something. I like this because this summarizes my talk very well. The goal is not to bend developers to the will of some specific patterns, but to get them to think about their work and what they're doing. Think, interact, communicate, get feedback from other guys, understand what you're doing, if what you're doing is right. Okay, I think that's about it. We can move to some questions. I finished 2 minutes earlier. Thanks.
All right, check. We have 10 minutes for questions, so raise your hand and I will throw this.
What is this box?
It's a microphone in a box.
Microsoft box.
It's soft, so you can throw it at people. Over there?
Actually, if somebody, for some reason, needs to connect, feel free to find me somewhere. Okay, now I understand why it's a box, because he's throwing it at people.
Just speak.
Okay, hi. So, really nice lecture. So, what do you think, how the evolutionary design, like evolutionary principle fits in that domain-driven perspective? Of, like, how to do the same thing, but under the evolutionary perspective, not the other one more.
I'm not sure I'm understanding the question.
Are you familiar with evolutionary design?
Yeah, but I don't understand the question.
Okay. So basically, with the example with the card, you showed like this is the first version, and after that you have different versions that are separate and stuff. Some would argue that you don't know that this is the right direction to change. You know, the change has price, and this may not the right direction to change in that moment, especially if you're a startup or something.
Okay.
So
I agree.
yeah, because here we see the result of the change, but we don't see the path. So can you say something about the?
Okay, I think I understand the question. So, is this the only path? No. Is this the right path? I don't know. That's the reality. I gave you a hypothetical situation where we started with a small team developing one shopping cart, which expanded into a big enterprise with different agendas. So maybe if the agenda of accounting actually includes the agenda of marketing, maybe this was not the correct way to split the design. So maybe we need to do a different type of design, but this is what I said. Single responsibility principle is about people, okay? So people, people's needs, people's responsibility. In a company, you have two things. You have responsibility and you have accountability. So single responsibility principle is actually more about the accountability side. So if you're accountable about the checkout process, you want to control every aspect about the checkout process. So this process should be split in a class, package, whatever, depending on the language and the system, and you should control every aspect of this. And you should provide a service or an API that others are going to consume. Did I manage to answer your question? Okay, he said yes. Nice.
Great. All right. Other questions? Yep, over there.
Hello.
Hey.
Okay, my question is, how do you deal with data storage when you separate things like that? And if they're in separate databases, how do you deal with atomicity?
Can you try, sorry, I don't get the words. Can you try speaking louder or closer?
How do you store the data when you separate things like that in these separate domains which are released separately? Are they like microservices? How do you deal with synchronizing data and atomicity of transactions?
Well, mate, those are quite a lot of questions. So how do you separate the data? How do you manage the transactions? How do you manage concurrency or something like that? Is this what you said?
So can you actually pick one question?
Just, okay, try to make it one question. Come on, I cannot answer 5 questions with a couple of sentences.
If the data is stored separately, how do you deal with sort of distributed transactions or atomicity of operations?
Okay, so far as I understand, if the data is, I'm sorry. Can somebody repeat it? Maybe, okay, come to me or I'll come to you. Come on, say.
Yeah, let's do this after the talk. After the talk, because we might have other questions. So if you have like a more complex question that requires some back and forth discussions, please come to
Yeah,
Martine
you can
after.
come visit me at the booth downstairs. Yeah. We have a booth on the 5th floor. or we can do it somewhere around, it's fine.
Any other questions? We have
6 minutes.
Yeah, 6 minutes. Over there again. Over there again. Can you raise your hand and actually stand up? Yeah, please stand up.
Yeah, but please try to keep the question to one sentence, okay? Because if I have to remember a couple of questions, I will fail to answer.
Any practical advice on when we should make this separation? Because obviously you can't know everything upfront.
Any practical advice on when you should do that kind of separation? Well, this kind of separation, as I said earlier, actually, during the talk, you should do it based on frequency of changes and scope of changes. As I said, if we have this method, let me try to open the slide. Okay, that's the original design, right? So if we have this method changing every week, probably we should separate it because this forces us to rebuild, retest, and re-release the entire shopping cart. Probably we should make it some kind of a service. I actually don't see which method I picked, so don't hold me on this. I'm without my glasses, as I said. So maybe it's this one or whatever. Now, you should, if one method forces you to rebuild and release your entire application, you have a problem. You should split it. However, if you start splitting before you have any frequency of changes going in that direction, this is called needless complexity. You should not have needless complexity in your system. This is why object-oriented design is so complicated. Because if you focus on actually doing a good split from the very beginning, you end up with 20,000 objects with one property and one method. But if you actually do everything in one class, then what, 5 developers are going to check out this class every day and try to commit their work at the end of the week. And then there will be 2-3 months of merging and debugging. I don't know, did I answer your question? Thanks.
Yeah, there's
Others?
one more question over there.
Yep. Shoot.
So what is, you talked about the first principle, which is the most important and the least understood, which is the second, which is also important but not that understood.
So which one is the second most important principle? Well, you cannot implement single responsibility principle without actually using the other 4. This is the funny thing. We can do the other 4 more or less without the single responsibility principle, but in order for you to achieve SRP, you need to use the other 4. So basically, they give you the mechanisms to actually do it. So all of them are equally important. But again, there is a very good metaphor, I think it's from Robert Martin as well, about painting. You know, paint, can of paint, bucket of paint. If you want to paint a wall or a fence, you can do it without reading the instructions on the can. But eventually, you should not ignore them. It's always better to know the instructions, to read them and to understand them, and then decide not to follow them. But it's not okay not to read anything, paint the wall, then try to sue the paint company because your dog died for some reason. So all of the principles are equally important, but they're equally useful, but eventually you should apply critical thinking and decide. If you decide not to apply a principle, you should know why. You should know, okay, we have a very performant system. We cannot have multiple components talking to each other. This is giving us some wastes. So we need this system to be super fast, and we are going to break this specific principle in that specific case because of that specific reason. So you should know that. Did I answer your question? Okay, thank you. I think we have 2 minutes more, or we should end?
Yeah, I don't think we'll have for one more question, but you will be here and also at the booth.
Yep.
If you want to talk to Martine.
Okay, guys, feel free to drop a line if you need me. See you around.
Sure. Big round of applause, please. Before we head off, just one very important thing. I will say it in 2 languages. There's a person that lost a jacket, a green jacket with keys and documents and everything inside. So if you happen to find a green jacket, please just find someone from the team and give it to them. And now in Bulgarian. Някой си е загубил зелено яке с документите и ключовете. Ако го намерите, моля някой от екипа да му го връчите, защото е неприятно. So 20 minutes break, be back here at 3:20. That's it. We are starting in 13 minutes. That's 1 3. 10 plus 3. We are starting in 10 minutes. 10 minutes until the next speaker. We are starting in 6 minutes. 6 minutes. Five more minutes. You can start taking your seats. All right, people, 4 more minutes. You can start taking your seats. All right, 3 more minutes and we're starting. 3 more minutes. Starting in 2 minutes. Starting in a minute, so please take your seats. We are starting in a minute. All right, so people, please take your seats. Still people pouring in. All right. Did you manage to get some coffee? I'm not hearing you. I think there is no coffee in play. How are you feeling? Tired or not yet? Very good. Come on, let's get some energy. Woo! Yes! Our next speaker is Robert Avram. Robert is a software engineer currently working at Reve Digital at Cologne and spends a lot of his time writing microservices in Clojure and Scala. His talk is, does functional programming actually help in production? So please, a warm welcome and a big round of applause for Robert.
Right. Hello. I do have to say this is a bloody big hall. I think it's the biggest hall I've ever spoke in. So thank you for having me. Thank you for coming to my talk. My name is Robert Avram. I've been told today that I'm a software commodity, and I work for these people. Now, I do like working for these people out of two reasons. The first one is that, well, they pay me, so I get to live, which is nice. But the second one is, and of course more important, I get to use excessive amounts of these in my day-to-day job. Now, I do have to still use some of these, but the first ones eclipse the second ones by a large margin. Now, these two things are two programming languages. They're Clojure and Scala, two functional programming languages. How many of you have heard of them? A lot of you. How many of you use them, either of them? Some of you. Brilliant. Now, this means that I get to do a lot of functional programming every day, and I get to use it in a big ecosystem-y, ever-changing, complex, every buzzword you can think about environment. And it's quite fun simply because at such a large scale, you sort of see exactly what you can squeeze out of a paradigm in order to help you. And basically, that's why I'm here. Now, first things first, what is functional programming? How many of you do functional programming? Okay, a lot of you. How many of you have read functional JavaScript or functional programming in Java? Okay, that's good. So this thing is basically a programming paradigm, and it's a fairly odd one because it just simply enforces a discipline. And the discipline is you should program with functions, hence the name. But it also says that these functions have to satisfy three rules. The first one is totality, determinism, and purity. And if you build a program where all of the functions satisfy all of these three rules, then your program gains some interesting properties. Now, the question is, what can functional programming promise? Can it make application improvements? Can it make it faster? Can it make it better? Can it make it less error-prone? Now, the answer to all of these questions is generally no. Like with any other paradigm, this solely depends on how you implement your application. But can functional programming improve the way that we as developers sort of build an application? And the answer to this question is probably. And I'm here to argue this probably. Now, what I'd like to do is I'd like to talk about properties that we value of code bases, things that we talk about very often amongst each other, things that we value, but we don't know exactly how to achieve because they're fairly difficult to achieve. And these are a number of ITs. I've picked 5 of them. There's modularity, there's testability, composability, concurrency, IT, and manipulability. And what I'd like to do is I'd like to go through each one of them and show you, hopefully, how functional programming might aid their achievement. So it's not going to guarantee them, but hopefully aid their achievement in the process. Now, modularity, what do I mean by this? What I mean is how we semantically structure our code, how we put pieces of code together in sort of structures in packages, files, objects, modules all together in order to achieve some properties. Now, the two most common properties that we want to achieve by doing so are isolation and searchability. Isolation is sort of driven by separation of concerns. We put code with the same concern together because if it's in the same context or domain, I can understand it better. But this has an immediate consequence, namely if I want to search for something that is from that domain, I know where to look for it. Now, these two are fairly difficult to achieve, and there's a lot of people in this world that had opinions about them, they wrote books about them, and they sort of led to programming patterns that more or less work. And two of these patterns are the service layer pattern, repository pattern, amongst a bunch of others. How many of you have heard of these patterns? Okay. So I'd like to basically go through them and see exactly what they do. So the service layer pattern and repository patterns are a way to semantically separate code. Service layers typically do or contain business logic, and repositories contain low-level effects, generally related to information retrieval and information storage. And the way we built them is by means of a combination of two things. On the one hand, dependency injection, on the other, object composition. So what tends to happen is that these things tend to be objects, and they receive other objects as dependencies, other repositories or services, that feed into the methods of these objects, and the methods use them in order to implement whatever they need to implement. And these sort of satisfy or create these two properties. I have now two isolated pieces of code. I can search for them because I know where they are, and I can understand them individually. But by doing so, you create two problems. The first one is that it could very well be that methods in these objects don't use all dependencies, but you've parameterized the whole entire module. The second problem is that these methods are encapsulated. You've put a barrage of things in front of them, and that limits your access to them. In order to get to these, you have to go through this and this. Now, if you would like or would want to debug one of these methods, what would you need to do? Well, you would probably need to instantiate or inject all of the dependencies. You would probably, depending if you use a framework or not, spin up an application because it needs loads of configuration. You would need to orchestrate a scenario where this method gets called. You would need to start a debugger, and you would need to click yourself into oblivion until you actually find the thing that you want to find. So there's a lot of things that I have to do just to look at one method. So can functional programming improve this? And I think it can. Simply because in general, functional programs tend to be very static. Because of the discipline that we follow, functions tend to be very stateless. They don't influence the world that much. They're pure. We also use immutable data, which means that we have a lot of invariance and a lot of determinism, which means that functions can be open and accessible. I can make them static. I can call them from anywhere. Now, you can still clump functions together into service functions or repository functions, but instead of putting them, encapsulating them away in objects, you can just put them in a namespace, which is just a prefix for that function. So let's look at our example, right? How would this look like in a functional setting? So you throw away the entire object and you just have a namespace. It's just like a prefix for your functions. And this thing contains only the functions that it needs to have. And the functions themselves receive the dependencies that they need in order to do whatever they need to do. And they're open, and I can access them from anywhere and call them from anywhere. So how would you debug this? You would look at a function. You would just write a main anywhere, prepare some data, and call the function and see what happens. Now, this is dumb, isn't it? But dumb is simple and dumb is quick. And if you have thousands upon thousands of lines of code and about 19 services to take care of, you need dumb and simple in order to get your things done. You don't need orchestrated and architected in order to fix problems, because that would just make you program in anger. Now, testability. This sort of is related to what I've said before, namely structure influences both debuggability, modularity, and testability. If we look at our previous example, how would you test one of the methods in this? Well, probably in the same vein as you would debug it, right? You would need to inject or selectively mock all dependencies. You would probably need to start up a fake application, depending on what you use. You would need to orchestrate a scenario again, and then call the function and see what happens. Now, how would you test this in a more functional setting? Well, you would prepare some data, and you would call a function. Well, almost I lied. That's not actually true. That's simply because functions are complicated, right? Functions don't do just simple things. They do side effects. They influence the world. They change what is around us. But functional programming has an answer for this thing as well. Namely, the discipline also forces you to split the functions that you have. And it forces you to split them into pure functions that only do data transformations and side-effecting functions that actually do I/O. Now, if you apply this, you'll also notice that you start testing in a separate manner. You'll start testing your pure code in one way and your side-effecting code in another. And if you continue doing this, you'll all of a sudden realize that your pure function must be as logically dense as possible, simply because you want to test them on a data level. And this basically becomes what I said before: prepare some data, call a function, see what happens. And in this case, you would probably do some property-based testing because this becomes more accurate. Your side-effecting functions will become extremely dumb and extremely simple, probably also extremely many because they're as simple and as dumb, but they should do one thing. You write a database, you read from a database, but you don't do more than that. And you would tend to want to test them integratively. So you won't want to mock anything because you want to test the side effects. So if you want to write a database, you're going to spin up a database, write a database, and see what happens. Now, in our closure project, this is so ingrained in our architecture that we have separate packages for each one of them. So if you take a look, we have two resource folders, source folders, one source and one source int. Source is for data transformation, source int is for our side-effecting transformation. In the same vein, we have a test and a test int, so we test them separately as well. Now, the upside to this is that your tests become accurate and localized. You test separately, and you concretely concentrate on whatever that thing is doing, and you're trying to gain as much as you want out of it. The downside is that you're probably going to write a load of tests, additional tests, just because you've separated them. Now, every time I tell people about this, the argument that they yell back at me is, well, in programming, functions are not the sum of their parts, right? If I have functions that I use in my implementation, if they work, doesn't mean that my implementation works. And the answer is it's probably true. Functional programming doesn't simplify testing. Complicated code will remain complicated, and the way you test it solely depends on you. But what I can guarantee is that doing this will remove some worry about the constituent parts of your program. And if you try to test something complicated, where you know that the constituent parts will behave exactly as you expect, it's much simpler than trying to test it full on. Next thing I would like to talk about is composability. Now, this sort of implies a bit of reuse, right? If I write some piece of code that I compose into another part of my program, I can reuse it there. And in standard object-oriented fashion, this comes in the form of object composition. How many of you know of object composition? Okay. Actually, all of you should know of it because I've shown an example of it. So this thing is built with object composition. Basically, you have an object, and you compose other objects into it, basically as dependencies, and it receives these objects and uses them in order to implement something. Now, in functional programming, this comes in the form of function composition. And basically means that if I have a function that takes an int and spits out a string, and I have another function that takes a string and spits out a byte, because the output of one function is the input of the other, I can put them together, and I get a third function that does both at the same time. Now, one interesting thing that functional programming has, another type of composition that no other paradigm has, is effect composition or side effect composition. You can make side effect compose together. And the most compelling example of this that we also use almost everywhere is that you can make errors compose, or computation that returns errors or throws errors compose with each other. So let me give you an example. Imagine you have a user job, you have a batch job, you compute for every user in your system. And this thing has to do a lot of things, right? It has to talk to a database to get some data, it has to talk to some services to get some data, and uses this data to compute some data out, right? Now, because each one of these calls go outside of your system, they most probably can fail. What you actually like to do, however, is if one of these fails, you wouldn't like to fail the entire batch job. You would like to skip it, log something, and then continue, right? So how would you go about solving this problem? One way would be to handle each and one of these calls. The problem with this is that you have to find a way to then break out of the execution but continue with your batch job. And this also sort of pollutes your logic with error handling. Another way would be to keep your logic clean and do a try-catch at the end, right? But again, you would still have to find a way to go back, skip this execution, but don't kill the entire batch job. And second of all, if you push try-catches away, at some point you have to do them. And they might reach a part of your program that doesn't really make sense because it's not related to the batch job at all. So how do you solve this problem? One way of solving it is by making errors compose. And the way you do this is by defining errors as a data structure, or computation that can return error as a data structure. And your functions, instead of throwing errors, would return this data structure. Now, the way you do this is by making a small observation about how computation works. Every piece of computation can have one of two outcomes. The first one is a success, whereby you get the result of your computation. And the second one is a failure, wherein you get the error of your computation. It might be a stack trace, a string, whatever you want to define as an error, right? So any piece of computation is actually a disjunction. It can either be one or the other, more or less like Schrödinger's cat. Now, ironically, you can actually encode this into code. And I've picked Java as an example because I think most of us understand Java. And this is represented through an interface called either. How many of you have heard of either? Okay, some of you. So either is basically a type, an interface that has two type parameters. On the one hand, it's the type of your error, the one that you want to throw. Could be a stack trace, could be a string, whatever you want. And the other one is the result type of your computation. And this thing has two instances. The first one is a success, and this instance only contains the result of your computation. The other one is a failure, and this thing only contains the error of your computation. Now, the way you use this is that if you have a function that will throw errors, you use this type to represent the fact that it might return two things. You say, my getUser function might either return some sort of throwable object, or it could return a user. Now, in Java and languages that don't have this built in, you have to do the side effect. But after you've done it, you basically just instantiate one of these two classes. If it's a success, you say success of the outcome. If it's an error, you say failure of the exception. And now these two things are data. Now, the brilliant part about this is that they now compose. So if you have a function from int to either of error to string, and a function from string to either error to byte, you can put them together. You get a function that does both of them at the same time and returns either of error or of byte. Now, the brilliant thing about this, and it's due to the semantics of this data structure, if the first one fails, the second one never executes, simply because you're in the failure branch and it doesn't have anything to feed the second computation that you've composed it in. So you have basically like a built-in circuit breaker. So let's look at our previous example. If each one of these calls would return an either, I could compose them together. Now, my logic would be a bit polluted by this data structure, but because it's data, it sort of still remains a bit clean because it's data that I return. If one of these things fails, then the whole execution stops, and I get a failed. But I can filter this failed out of the batch job later on, so I can basically, I don't kill the entire batch job. And I can handle this either whenever I want. And plus, I can also compose other computation that happens later on within this data structure, so I can basically merge it with my entire program. Now, the next thing that I'd like to briefly talk about is concurrency. And I'd like to talk about concurrency simply because it's sort of conflated with functional programming. People tend to say that with functional programming, concurrency sort of goes away. But I'd like to tell you that it isn't going away. Functional programming is sort of good at some problems of concurrency, but some of them remain the same. And what it's good at is three classes of problems. It's good at concurrent reads, at data distribution, and at composition of concurrent tasks. Now, concurrent reads simply is due to mutable data. If I have mutable data, any thread can read it, and if they try to change it, they get a copy. So that's fine. Data distribution is sort of like the inverse of this. Because I have immutable data, I can distribute it on any node I want, and it basically is never going to change. They get copies of it. Now, the last one is actually quite interesting. In functional programming, concurrency is a side effect. And much like the either data structure before, it's represented with a data structure. And because it's like a facade for concurrent tasks, I can compose other concurrent tasks into it. And the ironic thing is that you actually know what it is. It's the humble future of promise. How many of you use future and promises? Okay, if you use JavaScript, this is basically everywhere in your code. Now, future and promises come from functional programming, and they're just a representation of something happening concurrently. And much like the either data structure, they compose. In JavaScript, the composition primitive is then. Now, the brilliant part of this is that even though they compose, each one executes concurrently, there's a guarantee that is set, namely the callback that you give this future, the transformation that happens at the end, is guaranteed to execute sequentially and once all the futures complete, and it's guaranteed to also execute when all of them successfully complete. So what's this good for? Well, it's good for if you have something like this. If you have a function that calls a number of services and returns some data and it needs the data to compute something, this is what functionally good programming is good at. If you make each and every one of these calls a promise or a future, it will work exactly as you might expect. But for problems where you have some inherent common mutable state, imagine you have like a chat application where you have like an observable of some kind that you have to manage, like a session of some kind, then this doesn't really work. There's nothing in functional programming that can help you with this problem. You have to use standard solution for this method, like software transactional memory or semaphores or what have you. Now, there are functional languages that built this thing, built these features inside. Clojure has these, but there's nothing inherent functionally about these things. They're just standard solutions. And the last thing that I'd like to talk about, and then I'll leave you alone, is manipulability. And what do I mean by this? Is the way we program with data. Now, most of programming that we do just involves transforming data, right? What are HTTP requests? They are bundles of fields and values. They're lists of hash maps. What are classes and data classes? Well, they're fields and values. They're hash maps. What do I do when I validate a request or a class? Well, I have an operation or data structure. What happens when I transform a request or a class? Well, I have another operation on a data structure. Most of programming involves using data and either associative or accumulative data structures, namely hash maps, dictionaries, sets, vectors, what have you, and transforming these into something else. And this is basically the computational model of functional programming. Everything you do in functional programming is apply functions to data, apply functions to data. And this is so ingrained in the paradigm itself that it developed abstractions, mathematically proven abstractions for operation on data. And you can sort of clump them into three types. You have transformations between data structures, which are called endomorphisms. You have transformations from a data structure to a value, which are called catamorphisms. And you have transformations from a value to a data structure, which are called anamorphisms. Now, ironically, you've probably used them. If you use Java streams, things like map, flat map, filter, collect, these are all endomorphisms. If you use things like reduce, find, first, for each, these are catamorphisms. The same goes for JavaScript and a lot of other languages, and all of these come from functional programming. Now, how many of you do Java? Some of you. How many of you transform lists using the Stream API simply because it's more convenient? Okay, most of you. So this isn't really that far-fetched, right? It's quite useful. Now, functional programming languages are rich in data and data structures, and are richer in the operations that they provide for transforming data and data structures. So if you truly do programming with a lot of data transformations, I'm not talking about big data, but general, just programming like that, you just move data about, then a functional language will most probably help you more than any language would. Now, as I've said, I'll leave you alone after this. What's the conclusion to my talk? Which is apparently shorter than I expected. Functional programming is not groundbreakingly complicated. The deeper you go in the paradigm, it does get complicated, but I don't have to go deep in order to use some of its novelties to my own benefit. What I can guarantee you is that things won't change that dramatically. You'll still think about problems the same, you'll still approach problems the same way, but in time you'll notice that some things will change. Simply because it circumvents some problems that you used to think about before. So if you wanted to isolate, debug something, this is already there. Compound error handling and error composition, you already have it, concurrent calls, and a bunch of other things. And one of the most interesting things that happened, which I've noticed throughout time, is that it sort of absolves subtle worries that we have about code and data, and in particular worries that we have about time. Because we use immutability and because we use a lot of data transformations, once I've defined something, it's going to stay that way throughout the lifetime of my program. So I don't have to think later on what happens if I do this here. Would it influence something that I've done 2 days ago? So generally, functional programming programs have a higher degree of invariance than other programs. And invariance is good in big systems because you won't get errors where something that used to behave some way before behaves today differently. Now, I do thank you for your patience. I do thank you for your presence. And if you have any questions, feel free to ask them. Thank you.
We have time for questions, all right? Here. Ready?
Hey.
Hi.
So can you tell me one type of problems that the functional programming way is bad at?
For one type of problem?
Problems, yeah. Like, most of the times when somebody have a lecture for functional programming, it's always like, this is better, this is like kind of the same, but never this is bad.
So I thought one example, and this I've had to implement this summer, is exactly this. If I can go back to it. Generally, when it comes to things like these, you have to do a lot of calls everywhere just to gather information and then transform that piece of information to something else. The abstractions and the things that functional programming gives you allow you to do this in a fairly compositional manner. And that means that your code tends to look very much as if you were doing it locally without any side effects at all. So talking to a database, you don't have to think about, oh, does it throw an error? Oh, does it talk concurrently? Oh, does it do this and that? Generally, you have something like an either or like a future, or there's other things for these things that where you pretend this thing is happening and you compose it with other things and it basically looks normal. You just say, oh, it talks to a database, I might receive an answer. Talks to the service, I will receive an answer. And if one of these fails, then it's guaranteed that the whole execution sort of will stop. And you get some valid answer at the end that you can sort of interpret. But when you implement this, you don't have to worry about any of that because this is sort of taken care of for you. So these are types of problems where functional programming is good at. If you want more, then talk to me after this talk. I have a bunch of examples. Any other questions?
Right. More question.
Yeah. Hey, and thanks for the great talk. My question is, from your experience, what kind of use case would you not use functional programming for?
Game development.
Sorry?
Game development.
Okay, fair enough.
Or systems programming, because there's no proper functional systems programming languages as of yet. Rust is somewhat ideal, but it's not as functional as you might expect.
More questions? Stand up, please.
Yes.
Hi. Do you think that functional programming proving has a place in production?
You mean theorem proving? Or what?
Yes, like proving that the program works in a functional way.
Well, that depends on what you mean by production, or how you define production for a web application of some kind.
Maybe, for example, a backend service or a desktop application.
Less. So the guarantees that the paradigm provides as a whole, I think, are sufficient for that. Domains where proving might be helpful are things like, I don't know, think of NASA, where you sort of need to know exactly that the program works exactly as it should work, otherwise you lose billions of money. That's where probably theorem proving would work, and also things like fraud detection, where you have a bunch of sensitive information, but a back-end system, I don't think so. You could try it out. If you do it, I will be thoroughly impressed. But I don't think it's really necessary in general production system.
Right. More questions? Come on. We have time. You just have to raise your hand.
We still have 13 minutes, as far as I can tell. So. If not, then
perhaps while you're thinking about your question, I will ask a question.
Ask freely.
You mentioned you're using Clojure and Scala.
Yeah.
For production apps. Why don't you go all the way and use Haskell, for example? Because Clojure and Scala, they have imperative escape hatches.
Well, I could give you the stakeholdery answer and the developer answer. The stakeholder answer is because Haskell developers are fairly hard to find. And the developer answer is because Haskell is a bit complicated. It has it's not as complicated as you might think, but it has quite a learning curve. And ironically, we used to have a service written in Haskell. It just read Kafka and wrote to a database and was subtly deployed in our environment of about 150 microservices. Nobody noticed it because it just did its job. But one day, one of our architects saw it and he got a bit mad because if you want, in our case, to deploy some new service with a new language, you sort of have to go through the architecture board and tell them, I want this new language because I think it's pretty. And if they accept, you can use it. Otherwise, it doesn't. The thing is, the second or the third reason is because we have sort of like the JVM as our basis, runtime, and a lot of our other services are built with Java, and we use a lot of libraries as a whole, which are Java libraries, and if you use Clojure and Scala, you can directly access them because they have full interoperability with Java, and it's sort of akin to our whole platform. But there has been thought about this in my team, and we tried at one point playing a bit with Frege, if you've heard about it. It's sort of like a Haskell port for the JVM, but it didn't satisfy our needs, sadly.
Thanks for the answer. More questions? Or there, oh, yep, there are. There was a guy before you. There you go.
Yeah.
Thank you. I was curious, what kind of application are you writing on Clojure?
What do you mean exactly?
I mean, you have some some project that you are using this. I mean, what is the real world case that you are using this Clojure on?
What's the real world case? So our service is basically the main service that handles orders. So what we do as a company is we have an online shop, an e-commerce platform where people can order their groceries and we ship them to them. And our Clojure application is basically the order service that handles all the orders. It's fairly critical within this thing. And first of all, we chose Clojure. I wasn't there when they chose Clojure, but they chose Clojure because it's a simple, very terse, very powerful language. And a lot of its things, a lot of its features, both the immutability and the way this whole data transformation thing that I've talked about is very helpful. When you have a bunch of orders with a bunch of data that you need to sort of validate and transform and think about and map to something else and sort of put in other services and put in Kafka and whatnot. And it's very helpful for that particular reason. I don't know if that answered your question.
We have one more question here.
Yes.
Hi. So my question is, how do you decide when to use property-based testing?
Good question. That's generally, this is my opinion. It's not a team opinion, but it's the way I think about it. If I can think of a property for the thing that I've implemented, then I'm going to use property-based testing for it. If not, then I'd have to either think about it for longer, for which I don't have really that much time, or I just have to test it the normal way, unit test it or what have you. So there's no general rule when we use property-based testing, but the general idea is if you see a property or you feel like there's a property in this function that you've implemented, you should probably use for property-based testing for it. For this thing, we use property-based testing to test it. A derivative of what I've given this as an example. Any more questions?
Any more questions? Yep.
Okay. Yes.
Okay. I'm not sure that's a right question for you, but why Clojure and Scala and not Java, for example, with libraries for immutable objects or immutable data and streaming and so on and so on? I'm pretty sure that what you told us is some kind of idea that you can express on pretty much every language in 2019, more or less.
So to repeat the question, why Clojure and Scala, not Java, with some library that uses immutable data and transformation and so on and so forth? This is simply because these languages were built with these things inside of them, and they support them in a much natural and first-class fashion. I don't particularly like languages where you bolt on features on top of them simply because you can encode them in the language itself, but the language itself is not built for these features. There's good examples for this in Haskell. So even though you have libraries in Java for these, the language itself, both syntactically and semantically, was not built to support these things. And you notice when you use them that there's a lot of clutter, there's a lot of things, verbosity that you have to use just to get to the same thing. Whilst if you take Clojure or Scala as an example, you can express the same thing in much, much less code and a bit more concise and expressive. So yes, a solution to this, which also other people in our company do, is they take Java and say, I don't have any alternative, I'll take some library like Vava, I think it's called, and we'll try to use that. But you notice there's a noticeable difference between the same thing implemented with Java in a library and something implemented with Clojure and Scala. And I'll guarantee to you that the Scala version, if you can't understand Clojure, is much simpler to understand than the Java one. Any other questions?
Right. Any more questions?
Back there.
Up there. And I think this will be the last one.
So would you say that you use functional programming as a middle layer between your services just to map data from one service to the other?
Not really. We also have a lot of logic in between. So most of the things that we generally do is map data between services. If you have a microservice architecture, you realize at some point in time that everything you've learned at university is basically useless. Everything that you will do is map models to models because people are clever and think my model is better than yours. But we also do have logic, so there's much complex things that we also have to take care of, like making sure that the right amount of money gets paid and calculating things like, I don't know, differences between orders. And there's a lot of things that we also do in addition to just mapping data from one point to the other. And all of this is done with functional programming.
All right. Let's thank Robert again. He will be here if you want to discuss further with him. We are taking a break and we'll be back here at 4:10 for the next lecture. Next talk is going to start in 10 minutes. Next talk is starting in 5 minutes. That's 5 minutes to the next talk. All right, next talk is starting in 3 minutes. You can start taking your seats. Two more minutes. We are starting in 2 minutes. One more minute. Okay, we're starting real soon, so please take your seats. All right. There's no need to hurry. Don't worry. Okay. So, the mandatory question, how are you feeling? Come on, come on. How are you feeling? Woo! Yeah. So our next speaker is Alexander Georgiev, who is a senior software engineer at Skyscanner and also a well-known teacher from the Faculty of Mathematics and Informatics here in Sofia. His talk is going to be what the fuck languages, so please, big round of applause for Alex.
Hello, and thank you for coming here today. This talk has a really strange name, and thank you for joining it, although it's odd. Although Radu introduced me, I'll introduce myself as well. A little bit about myself. I guess many of you have already seen me because that's one site you've definitely visited recently, HackConf program. For some reason, Google shows my pictures here. I have no idea why. A little bit about myself. I'm currently working at Skyscanner for around 4 years now. Before Skyscanner, I was at Google and at Facebook. One other thing about myself, I'm an active competitive programmer for 15 years now, and also creator of Informatica BG, which you might have seen. And as Radu mentioned, I'm a lecturer at Sofia University. On this picture, you can see one very successful and famous person, and also next to him is Mark Zuckerberg. Yeah, that's from my internship at Facebook. Okay, this should change. Why what the fuck languages? Please notice the comma, because it's actually addressing the languages. What the fuck are you doing? Why are you designed in this way? You'll see why in a minute, but yeah. Without the comma, we would be talking about some exotic languages like whitespace or brainfuck or Shakespeare or JavaScript. All languages you wouldn't write production code in. But let's start now. But I'll start with a question. So first, questions to you. First, the baseline. How many of you are present? Okay, no one. A few people. Okay, so tough crowd. How many of you program in C++? By program, I mean have written at least 10 lines. Okay, much better. How many in Java? Okay, C#, JavaScript. Okay, quite nice. What else? PHP. Nice. Whitespace? Okay, never mind. I don't need a whitespace. So the first one is JavaScript. So you might have seen from the intro to the lecture this one, so might have already checked it out. How many of you were interested and checked it out? Just a few people. Okay, awesome. So what would you expect it to be? Like, we create a data object, we call get here. What do you expect to get? Shout out. 2019, that's a very valid thing. No. Other suggestions? The year from the year 1970, which is the Unix timestamp, I would also be okay with that. No. So the answer here is 119, which totally makes sense, I guess, because JavaScript underneath uses a really old C library, which gets its offset from 1900 here. So why not 190? That was surprising for me when I first found it out. Okay, next language, PHP. So what does the following print? If you're not familiar with PHP, we create an array with 3 objects, a cat, a dog, and a parrot. We print the count of the array, and then we print the 3 elements of the array. PHP does it correctly, prints 3, then cat, dog, parrot, as expected. So there is this other function, filter array, which basically goes through the array and filters out elements we don't want. In this case, we don't want the dog. So we do the count again, and we print the elements again. What do we get? I would expect we get 2, and then we get a cat and a parrot. PHP doesn't think like this. So it prints 2, then prints an undefined offset error, and then finally prints a cat. So that's really odd. If you don't know why, PHP deletes the element, but keeps the integer indexes of the elements, which totally makes sense. So we should print it with 0 and 2. Going forward, Python. So what does the following print in Python? So how many of you program in Python? I skipped Python for some reason, and it's quite an important language. Okay, a lot of you, just heads up, Python will be the second most favorite language in this presentation. I can guess you know the first. So A equals 42, B equals 42. Is A B? How many of you think it's yes? 3 people, okay, a little bit more. How many think no? Many more people think no. You'll be surprised that it actually is. If we get to a more unfortunate number, however, 13, and we do the same check, how many of we get true as well? If we get to a lead number, what do we get? A false. That's consistent. So if you don't know why, I'll help you with a hint, which is this is the first number. It is not true. Does it tell you anything? Okay, basically Python has predefined values for all numbers from 0 to 256, and after that it doesn't. However, the predefined values are reused, and there is to each other is true, and for all other numbers it is not. There is one caveat though. So if we define the numbers on the same line, it's true. However, in Python there are two ways to define them on the same line. So the other one being basically, the other one being with a comma, and we get a false. So that's, don't feel bad if you didn't guess it right, because the authors of the language, oh, come on, work, please. Okay, don't get upset if you don't get it right, because the authors of the language didn't get it right either until several versions ago. It used to be true. They changed it because it makes sense, I guess. C++, so for the fans of C++, what does the following print? Basically, we have a for loop, and we add 1/10 to a variable 10 times, so we should definitely get one right. No. Going forward, if we do the same but without the loop, we actually multiply 1/10 by 10. We should get the same, right? No. This time it's true. So going even big, here we have 1/10 plus 3/10 plus 3/10 plus 3/10, which should obviously be around 1. Is it true? Is it false? How many of you think it's true? Okay. How many of you think it's false? Many of you think it's false, but it's actually true. However, if we move the 1/10 last, that's the only difference here, we get a false, so that's fine. Okay, one more example I have. So 0.1 plus 0.5 equals 0.6, true, false? You don't know? Maybe I don't either. So it's true and false. To be fair, that's not a problem with C++ itself. It's a problem how floating point numbers are stored. So because of the standard that defines them, there are some irregularities, so we cannot represent some of the numbers precisely. And if we cannot present them precisely, we get rounding errors, basically. However, C++ does some optimizations in some cases, in which it thinks, okay, maybe you meant this, so I'll do it this way. So we have like quite inconsistent things. JavaScript. So we have an array of numbers for the ones that don't write JavaScript. That's an array of numbers. We check that they're numbers. They are. We do a sort. What do we get? It should be the same, right? Because the numbers are sorted. No. JavaScript sorts numbers as strings for some reason. Although after we sort them, we can try again whether they're numbers, and they are. But just for the sake of sorting numbers, they think maybe it's a good idea to do it as strings. Okay, Python. Before Python 3.5, the date object was considered false if it represented midnight in UTC. All other cases, it's true. C++. Is there a value for the variable a for which the following statement will print false? So what we print here is if the number is equal to itself. Yes, I heard a none, I think. So the none is the correct value. None is not a number, so this is the only value defined by the same standard I mentioned before, which compares different than everything, including itself. So yeah, we can get a none by dividing a 0 by 0. However, only if it's floats. If it's integers, however, it's not. That's fine, I guess. It prints true and a warning, though. Okay, Python. This one bugged me for a while when I started coding in Python. How many of you code in Python and have seen this? Like, this is the way how you concatenate elements of an array into a string. How many of you think that's not logical? That's not how you would do it. Yeah, just a few. That's interesting. Let's do the baseline again. How many of you are here? Okay, still less than half. Okay, that's fine. C++. So do you think there's something wrong with this code? How many of you saw what's the problem? Few of you, yeah. So the problem is that instead of indexing the array with the index, we index the index with the array. But that's fine in C++, so let's move on. Python. Okay, so maybe a bit explanation why this still works in C++. So C++ takes the value of one of the things and the value of the other things and adds them together, multiplying by the bytes and things like that. And what it turns out to do, no matter whether we pass the pointer and the index or the index and the pointer, the sum is still the same. So we access the correct element. Python. So this is my favorite slide. So true is true. That makes sense. If this works, I'll get to the next slide. False. True is false. That's obviously false. False equals false. That's also true. But if we know this, what will be true is false equals false? True. Yeah, true makes sense. It's false. So true makes sense because if we wrap the true is false at one side, we already saw that this is false, and we saw that false equals false is true, so it makes sense to be true. If we didn't get the precedence right, and actually it's true is in brackets false equals false, we get also true. But in Python, if you don't have the brackets, you get a false. Let's just move on and don't talk about this further. Python. So we have this code. We define a variable x. We do a try except clause. And in the except case, we define x as an exception. So we redefine the value. So now we also we always raise the exception. So we always overwrite x with the exception. So now the question is, if we print x, would we print 42 or the exception? How many of you think it will print 42? Okay. How many of you think it will print exception? Okay. So Python designed to does neither, which, as you can see, totally makes sense. JavaScript. So what will be the result of the following? So we have an array of strings this time, which are 10, 10, 10. And we map the array to with the function parseFloat, which takes a string and converts it to a float. We should get 10, 10, 10, I guess, which we do. However, what happens if we, instead of parseFloat, we pass parseInt? The same, yes, that's what JavaScript does. This happens because parseInt takes additional arguments, optional additional arguments, but in this case it sees there are some additional things, so it parses the 10 in the base given. So yeah, really consistent. Good job JavaScript. Python. Okay, I should move closer. So we define a function which takes one argument, which by default is an empty array, and we push the number 42 to the array, and then we return the array. So if we call the function, we would expect that the array returned contains 42, right? So that's what Python does. However, if we call it a second time, we get two 42s, and so on. So this happens because the default arguments, if they're objects, are being reused. So the first time we call the function, an object is reserved, and it's being reused every time we call the function. So this is really bad, but it's how Python does. So I've hit this several times. I guess you can hit it as well if you start writing code in Python. So be very wary of this. So this is really bad design. Python. Okay, what will be the result of this? We have a dictionary which has one element 0, which points to 42, and we print the key. All the keys basically in the dictionary. Obviously, we should print 0 because this is the only key, which it does. However, if we change the code a little and we delete the actual value and we replace it with the next key. So in this case, we'll have a 0, we'll delete the 0, but we'll add a 1 equals 42, and we'll continue this loop until it continues, basically. What are we going to get? please shout out suggestions. Stack Overflow, that's a nice one. No. Sorry? My suggestion would be an infinite loop, because you added the next element again and again and again. So Python, what Python does is print 0, 1, 2, 3, and 4, and then stops. The explanation here is the Python dictionary is actually a hash map. And inside this hash map, it has reserved size. And we iterate this reserved size basically in some way. And when we add the 0, it defines an element. When we add the 1, it defines an element after it, and then one after it, and so on. But at some point, it has to rehash, and the new hash value is actually before the current iterator, so it stops. And that apparently happens when we get to 5. Okay. Okay. JavaScript. What is the minimal number you can think of? That's not a trick question. Like, really think of the minimal number you can think of. Minus infinity, that's a good choice. It's not a number, but it's a good choice. So let's say minus 10. Minus 10 is a good enough example, I guess, in this case. So what do you think JavaScript thinks its minimum number is, though? Is it greater than 0? It is. However, if we get a math max, what do we get? Minus infinity, yes, that's great. So we know that the minimal number is above 0, but the maximum number is minus infinity. So far, so good. So let's continue with JavaScript. So JavaScript has some weird issues with types. So is the string instance of string? Obviously, no. Otherwise, I wouldn't show it. So we already spoke about not a numbers already. They're quite nice. They're not a number, which JavaScript clearly knows it is. Like, but that's also something that follows from the standard I mentioned before for the floating point number. So it is a defined number. It's just really strange number, which is not a number. C++. So in C++, we have those libraries, and we have those functions defining those libraries. And one of the functions is abs, which returns the absolute value of a number. However, it's defined in 4 different headers. So in Testability for ints, in CMAT for floats and doubles, in algorithm for long, and in complex for complex numbers. But since this wasn't enough, in 2011, well, at least in the standard 2011, 2 more functions were added to this for long and long form. That's nice, like 6 definitions of this function. Java. So Java doesn't have an unsigned type. I figured out that quite late in my life because I didn't write Java for a while, and then I had this Programmирование story course in Sofia University before the Programmирование story was led by Hack Bulgaria, and I asked my students, I showed them some problem with unsigned, and half of my students were like, unsigned? What is unsigned? And I'm like, how do you don't know what is unsigned? And apparently people in Java doesn't know what unsigned is because they don't have it. However, Java has arbitrary long numbers, which is quite nice, and C++ doesn't, which is really sad, and they don't introduce it again and again. But JavaScript has to be on top of everything. So Java doesn't have unsigned, C++ doesn't have long numbers, that's fine. JavaScript doesn't have integers. Yeah, the only supported number basically is the floating point number, which we already spoke is a pretty bad one. But yeah. Following this, what do you think this will print? So this just evaluates this number. It happens like. So JavaScript. We define a dictionary with key 42 and value foo. That's similar to the Python I showed you, but it fails in a different way. So if we take the value 42, we get foo, which we expect. If we define the 42 as a constant variable, which we should if we write good code, and we do the same, we get undefined, which is awesome. If we index 42, which we should have foo for sure, we still have undefined. And that's because JavaScript says, haha, I'm really smart. I know you have defined a constant called const val, But instead, I'll use it as a string. So if we index the const val as a string, we get a foo. So that's almost awesome, but we can continue forward. So if we have, this time it's bar instead of foo, so it's different, really different. So, and we index 42, that's okay. If we index 42 as a string, that's still okay. If we index 042, what do we get? Same, yeah, almost. If we index 052, though, we get what we want, so that's fine. The explanation here kind of makes sense, so don't laugh too much on JavaScript. So numbers prefixed with 0 are interpreted in base 8 octal numbers. So 052 is actually 5 multiplied by 8 plus 2, which is 42, so that's fine. However, to make it consistent, if we index it as a string, which we already showed should give the same results, it doesn't. It doesn't, yeah. There we go, Python. So what will be the result of the following? So we have a tuple. It has 3 elements. The first is 1, the second is 2, and the third one is a list with 3 and 4. And we add to the third one 5 and 6. This addition extends the list. It does modify it in place, so that should be fine. What isn't fine though is that tuples are immutable, so we cannot change indexes of tuples. So what do you think will happen? Will it crash or will it update the list? Okay, let's raise hands. So people here, please raise hands if you think it will add the elements correctly. Around half of you. How many of you think it will crash? I guess the rest of you, but that never works here. So, okay. So Python has a really nice interpretation of this whole thing. It crashes, but it also changes the list. Because why not? JavaScript. So this expression on the top line basically evaluates to a really large number because JavaScript changes things. So at some point we get 1 plus the string true index the third value, which after some thinking goes to the scientific notation for 10 to the 20th power. And so it prints 10 to the 20th power. Python. What will the following print? We have a tuple with 2 strings, string 1 and string 2, and we iterate the tuple and we print the strings. It should print the strings as it does. However, if the tuple has a single element, it prints the characters of the elements. And that's actually not a problem. Well, it is a problem with Python, but it's kind of the definition of Python. So if we have a tuple with a single element, it actually interprets the brackets as just a mathematical expression. So it evaluates the string to the string itself, and it just prints the characters of the string. To fix this, we should add a comma after the string, which is a really odd thing, but apparently this is how you define a tuple. Java. In Java, we cannot use primitive types, and the primitive type is an integer, long, or whatever, a long character, or whatever. So every time you have a vector or a set, you have to convert the primitive types to their base classes, which are integer and long and character, which takes a lot of time. So if you want to have a set of integers, you just have to spend a lot of time on this. I've run a test on this, so if I do it in a way in which I don't do the boxing and unboxing, it's quite faster. It's several times faster. So that's really odd decision, but okay. Java. So because of the non-reference to primitive types like integer and long and so on, you cannot do a swap function in Java. Don't know whether you've ever seen this, but it's quite annoying. Python. So what is the size of an integer in Python? So maybe you've seen C++, Java, all those languages. It's either 4 bytes, sometimes it's 8 bytes. Well, it's actually always 4 bytes, but never mind. So do you think it's 4 bytes, 8 bytes, anything close? Well, not really. So Python decides to have, like, instead of 4 bytes, it has 24 bytes for a 0. But if you have a 1, it's already 28 bytes. So that's like 1 bit more. That's certainly 4 bytes more. The reason why this happens is that Python has arbitrary long numbers, which are defined as a structure, and this structure keeps the digits in base 1 billion. So basically, every time we pass the 1 billion mark, we add another 4 bytes. So that's 1 billion in terms of logarithm. So don't know whether I explained this correctly. JavaScript. So what? So this is taken from another talk I've linked in this presentation. Some of you might have seen it. How many of you have seen it? Okay, did you like it? It was awesome. Yeah, I really liked it as well. That's why I decided to do this presentation. But for the ones of you who haven't seen it, what do you think an array plus array does in JavaScript? Empty string, yes. So if we do an array plus object, we get an object, which is okay. So if we reverse this, we should get the same, which we clearly do. And finally, if we add an object with an object, we finally get something that makes sense, which is not a number, if I change it. Yeah, so that's really consistent, as you can see, but we'll get to PHP and you'll see that JavaScript is actually quite the same language. Yeah, this is the link to the presentation. I think the organizers will send you the presentations later so you can see it. JavaScript. So, arithmetics in JavaScript, that's so nice. So 5 plus 3 minus 3, that's obviously 50. So 5 minus 3 plus 3, 5. Minus 3 plus 5 plus 3 is minus 353, but there's a string, so that's fine. 3 plus 5 minus 3 is 32. And the final permutation of all those numbers gives 0, 5. PHP, Have you ever heard the phrase consistent as PHP? If you haven't, there is a reason for this. I'll just leave you several seconds to interpret the max function that they've defined. Yeah, basically, if we have a number and a null, it depends whether the number is in the first place or in the second place, but also it depends on the number. And if we do it with a string, it depends which one is first, which one is second. And if we do a string and a null, we always get a string. PHP. So integer division was introduced 20 years after creating the language in PHP 7. For the people of you who are writing PHP, I'm sorry. Like, that's really amazing language. However, the integer division... that was really nice, but no. Nah. Okay. Now it doesn't move. Okay. It was introduced through a function, which is int diff. So if we want to do an integer division, we actually have to use a function. Python, and we're almost done. Python classes can inherit themselves, which is really awesome, like a snake biting its nail. That's so awesome. So if we define a class and we inherit itself, if we define a variable of this class, would we get the first one or the second? It kind of makes sense to get the second one, which Python does, so bravo, awesome. Okay, and PHP, so we get character Z, and we increment the character. What do we get? Suggestions, please. A makes sense, kind of, because it's okay. Someone else? 0, no. The character after Z in the ASCII table makes sense. What we get is actually AA. Because PHP really follows C++ and C as a language. Instead, in this only in this case, it actually follows other languages, which get the next string, basically. So if you have an Excel table and you know the columns are like named A, B, C, D, and so on, if you ever got to the column after Z, you get the column AA. So that's like awesome. So the last slide, C#. So in C#, if you have an if and you do a return inside it, you don't break out of the if. And thank you.
Questions, we have 10 minutes. Questions? Come on.
I think you'll have so many questions right now, but you won't ask them.
Yeah, I'm wondering who to choose.
What am I doing with my life?
Come on. Pretty sure. Oh, there's a question. Can you please stand up?
Thanks very much for the nice presentation. I'm wondering, what's your favorite language?
My favorite language? Tough question. I would say C++ for programming competitions. I would say Java for work and Python for some other types of work and personal projects. So it really depends on what you're writing. So for large projects, I definitely wouldn't recommend C++, and I wouldn't recommend Python. For really small things, I would definitely recommend Python. For really effective stuff, I would definitely recommend C++.
All right. Other questions? Oh, there's one.
I want to ask, do you have examples in Rust and Go?
Rust and Go, those are languages I don't write. So basically, I've included mostly things that I've faced. There are a few slides, like 3 or 4 slides, for which I just found a funny thing in Stack Overflow, and I decided to include it here. Most of the things I've faced myself, especially the C# thing, like the return. But yeah, so that's why I haven't included any.
All right, other questions? We have 6 more minutes, so something like 1 more question. We can go in a break.
I left them speechless.
Yeah, you've left them speechless. So, a big round of applause for Alexander. You can find him here to ask follow-up questions or to, I don't know, ask why he's nitpicking your favorite language. And be back here in 16 minutes when we continue with the next talk. Thank you.
странно. Има ли как да се скъси малка главата? Добре, така ще стоя. Какво стана? Има ли? А може ли да пробвам с твоя телефон, пак? Я пусни... Яме хотспот, не само трябва да я заредя. Че искам да пробвам и дали мога да увелича малко нещо. Има ли зум в кликалката? А това е напред. Напред и назад. Окей, добре. Ами мога да покажа тогава. Лимит. Какви защити има това? Минути имаме. Може това да е. Окей. Да, по-добре. Почваме, да. Да, т.е. ние имаме време да... Ами, тук малко. Виж. Моля, не ме.
So the next talk will start in 5:10, so this means approximately 18 minutes. There's time. Next talk will start in 15 minutes. Next talk will start in 10 minutes.